Lesson 20, Work. Our objectives for this lesson are first to define work, and second, to be able to calculate work based upon its definition. So let's start by taking a look at the definition. In science, work occurs when a force is applied through a distance. The important thing about this is that the force is applied through a distance. In other words, the force is causing movement. There are a lot of times that you could have a force and there's no movement. For example, you're probably sitting on a chair right now. You're experiencing the force of gravity, which is pulling you downward. But you're not moving downward. You're being stopped by the chair. So gravity right now is not doing any work on you. On the other hand, when you leave class and go down the stairs, gravity will be pulling you down the stairs. In that case, the force of gravity will be doing work by moving you through a distance. So in other words, work occurs when a force is applied through a distance or when a force causes movement. In order to calculate this, work, which we use a symbol of a W, is equal to the force, F, times the distance, D. Since there are three things in this formula, we can put them together into a triangle. You will want to put this formula on your formula card under mechanics, since this deals with forces. Now, the unit for work is derived from this formula. In the metric system, the force is measured in newtons and the distance is measured in meters. So we get a unit called a Newton meter. Now notice that this is a Newton meter and not a Newton per meter. We're not dividing. We don't use the word per, nor do we use a slash. When we have two things that are multiplied, but we put them together like this, instead of using a dot, we use a hyphen. If you want to use a dot instead of a hyphen, that is perfectly acceptable. But the idea is that they are multiplied together, and it's a Newton meter. One of the things that happens a lot when we have a combination of units, and it's used in a lot of ways, is that combination of units is given another name. That's what happens here. A Newton meter is also given the name of a joule. It's abbreviated as a capital letter J, and it's named for a scientist named James Prescott Joule. So a Newton meter and a joule are the same thing. In the British system, force is measured in pounds and distance is measured in feet, and we get a unit called a foot-pound. Once again, notice that the two run together, foot-pound with a hyphen in between, and are not a foot per pound. One of the other things to remember is that a Newton meter and a joule are the same thing, but a foot-pound stays a foot-pound. It doesn't become anything else. Let's try an example. A person applies an upward force of 60 newtons to a 50 newton weight over a distance of a half a meter. How much work is done in lifting the object? So we start by identifying what it is we're looking for, the work, and we put down our formula for work, either in equation form or as the triangle. Now notice that the first thing that we need is a force. But we have two forces. We have a 60 newton force, which is going upwards, and we have the 50 newton weight, and weight always acts downwards. So if we want to know how much force we actually see moving then, we have to actually go back to lesson 13 and figure out the net force. 60 newtons up and 50 newtons down means we're going to subtract 60 minus 50 and get 10 newtons. So we actually only see 10 newtons moving the object. We also need the distance, which is a half a meter. And our units are all in the correct form, so now we can substitute 10 newtons times a half a meter. And we get 5 Newton meters, because we're taking newtons times meters. Remember, a Newton meter is the same thing as a joule, so you can write it as Newton meters or joules. Now, just to recap, work equals movement. So if a force is applied but the object is not moving, there is no work. Let's see an example of this. A student holds a 2 Newton book 2 meters above the ground. How much work is done on the book? So as usual, we start by identifying what it is we're looking for, work, and we put down our formula. But the thing is, a lot of times students like to just go through and grab numbers. So we have 2 newtons in 2 meters. So that should be our numbers, right? But that's not the case. This problem needs a more careful reading. The student is holding the book. By holding the book, he isn't moving the book. Now, technically, we could say the net force on here is 0 because it's like you sitting on your chair. For simplicity's sake, we're just going to say that the force is 2 newtons. But the distance that he moves it is 0. So in either case, when we substitute our numbers in, whether it's 0 times 0 or 2 times 0, we're going to get 0 Newton meters or 0 joules of work. You must have movement in order for work to occur. So our final answer in this case is 0.